Yeah, so you finished up the lab and you probably got a graph that looks something like this, or hopefully you did, when you calculated your acceleration at different angles on the ramp. And you'll notice that the data, as you get up to higher angles and you're approaching, here is 90 degrees. When you're approaching 90 degrees, that curve seems to flatten off and it's approaching some value. And that value, if you're able to read over on the y-axis at 90 degrees, the value of the acceleration is about 10 meters per second squared. Well, that value is actually really, really important. That value is what we call the acceleration due to gravity, g. Because you can imagine if your ramp goes to 90 degrees, essentially your cart is just falling. It's no longer really traveling along the ramp, it's just falling. So that 10 meters per second squared is the acceleration of a falling object on Earth. And it turns out that all objects on Earth should fall with an acceleration of 10 meters per second squared because gravity affects all objects the same. But of course, you know from experience that if I take something like a feather and a hammer and I drop them, they're not going to hit the ground at the same time because the hammer is so much heavier, right? So you're going to see something like this and the feather is just going to float down to the ground. The reason for this is not because of gravity. Gravity is affecting those two objects the same, and they both want to accelerate at 10 meters per second squared. The difference is we have all this air around us, and air resistance actually slows down the feather and changes the acceleration from 10 meters per second squared to something much smaller. And what happens is the feather actually reaches terminal velocity. So it's traveling down at close to a constant speed after falling a few seconds. If we were able to remove that air resistance, so actually create a vacuum on Earth, then if you drop any object, no matter the size, no matter the shape or the material, they would all accelerate at exactly 10 meters per second squared, and all objects would hit the ground. When dropped from the same height at the same time, they'd all hit the ground at the exact same time. So this is what we call free fall. Free fall is falling under the influence of gravity only. If we remove air resistance, all objects on Earth accelerate at 10 meters per second squared towards the ground.